Hey, hi, hello, dear Swift learners. How are you all? I hope that you all are fine. And here I welcome you all to Swiflearn, which is India's most sincere learning destination. So I am Ritika and I am back for you, bringing with me another new session. And what is our new session about? We are going to see, but before that, we will see what is the platform at which we are studying. So we are here at Swiflearn, wherein you get the classes for grade 1 to grade 10. We have live and interactive classes with personalized batch of 6 students, and then we have academic mentor to track your progress. Apart from teachers, they will be helping you and will be guiding you. We also cover the syllabus as per your school exam schedule so that you can perform well in your school also. Plus, there are some of the more key features which make Swiflearn special. These include detailed progress report. Then we have Swiflearn academic test series, and you can take unlimited practice test which includes 2 categories, subjective and objective. So what are you waiting for? Just go and book your free trial class on Swiflearn and have this amazing experience of classes over here. And if you are new to the channel of Swiflearn, please subscribe to the channel and press the bell icon so that you do not miss out on any update, any amazing update of the lessons which are going on here. And also, if you like this video, kindly press on like button. Alright, so today we are going to do organic chemistry session number 5. We have completed a long 4 sessions. Alright, if you have missed out on any session, kindly go to channel. The videos are listed there. Please see them so that you can easily understand it step by step. But right now you got to be here to see what are we going to learn. We are going to see carboxylic acid today basically. Okay, then we will be seeing a little bit about esters. Okay, so we are going to cover this part of carboxylic acid and esters for today. Now, we have learned many things in these 4 sessions, right? We learned about various hydrocarbons, we learned about alkenes, alkanes, alkynes, etc. And we learned about alcohols, etc. So today we are going to start with carboxylic acid. Carboxylic acid. It is an organic compound which contains the group COOH. Obviously, they possess acidic properties. The name itself says carboxylic acid. Now, the general formula of carboxylic acid is CnH2n plus 1 COOH. Now, the general formula of alkane is CnH2n plus 2. What are we doing is, we are just replacing this 2 by CnH2n plus 1, and in place of this 1 we are adding a new group which is COOH, and this COOH group, it joins like C double bond O here and single bond OH here. So these valencies of carbon, it goes like 1 electron is shared from this group, 2 electrons they are shared here by oxygen, and 1 here. So it actually completes the octet. Now, the carboxylic acid is a group in which one COOH group, okay, it is there, and the acid in which there is one group, it is known as monocarboxylic acid. For example, if I talk about formic acid or acetic acid, they are having one COOH group, okay, and that is why they are known as monocarboxylic acid. Now, talking about the 2 COOH group, okay, and these are known as dicarboxylic acid. Obviously, we are having 2 groups and therefore they are known as dicarboxylic acid. For example, oxalic acid. Its common name, it is the nickname that we have given. IUPAC name is ethanoic acid. Okay, so there is a homologous series of monocarboxylic acid which goes like formic acid, which is the nickname we have given, and the IUPAC name, it is methanoic acid. Methane, 1 carbon, as you all might be very familiar with this thing now, okay, and oic acid is the suffix. Similarly, with acetic acid, it is ethanoic acid. For 3 carbon, it is propanoic acid. For 4, it is butanoic acid, and the common name which we have given to butanoic acid, it's butyric acid. So what is the general formula of carboxylic acid? It is CnH2n plus 1, where one thing that we used in alkane, we are replacing it by COOH. Okay, so the general formula is either RCOOH or CnH2n plus 1 COOH. Explain dicarboxylic acid with example. So dicarboxylic acid are those acid in which it contains this COOH group. Okay, so here you can see one group and another group. Okay, so the nickname is oxalic acid and its IUPAC name is ethanoic acid. Now we are going to study about ethanoic acid. IUPAC name, it is given by replacing E of the alkane by oic acid. Okay, same was in the alcohols also, we have seen that, right? So they are derived from alkane by replacing this one hydrogen atom with this carboxyl group. And the common name of ethanoic acid is acetic acid, and I'm sure many of you might have listened about it. Okay, next, talking about the structural formula. So how does it look like? So this is the functional group, okay, and it is added to this particular group. So these acids, they occur in free state in many of the fruit, and they occur as esters in essential oils. How is ethanoic acid prepared? Let us study about this laboratory preparation. So if I talk about laboratory preparation, we are preparing acetic acid by oxidation of ethyl alcohol, which is also known as acetaldehyde, with potassium dichromate or sodium dichromate and moderate concentrated sulfuric acid. So what are we doing? We are obtaining this by oxidation process. First of all, from ethanol we will be getting ethanol, which is aldehyde, and further oxidation will give us ethanoic acid. Next, other methods of preparation of acetic acid are, first is from acetylene. So what are we doing? If we pass 40% of H2SO4 with the condition of 60 degrees Celsius in the presence of 1% HgSO4, so these are all catalysts. Okay, what we can do, acetylene is converted into acetaldehyde, and if we further oxidize it, we will be getting the acid. So the obtained acetaldehyde, we are oxidizing it to acetic acid. How? By passing this particular mixture of this vapor, okay, over manganese acetate at 70 degrees Celsius. So here in all the things we have seen that the conditions, they play a very important role. So we have to be very particular about the pressure that we are applying, okay, the temperature that we are giving, because these all actually make the important change. Next is from ethanol. So by passing alcohol vapors over platinum black as catalyst, again at 300 degrees Celsius in presence of oxygen, acetic acid can be obtained. So ethanol, we are providing oxygen and the conditions are 300 degrees Celsius with catalyst as platinum black. We will be getting the acetic acid. Now we have studied a lot about acetic acid, and now we are going to see some of the properties of acetic acid. First, physical property. Pure ethanoic acid or acetic acid is colorless liquid, but it has a kind of very pungent smell. Its boiling point is 118 degrees Celsius with melting point being 17 degrees Celsius. It is hygroscopic liquid. Hygroscopic means it tends to absorb moisture from air, and specific gravity at 0 degrees Celsius is 1.08. And talking about their solubility, it is miscible. It is completely soluble in alcohol, water and ether. Okay. Next, chemical properties. So ethanoic acid, it is a weak acid and it turns blue litmus red. Second, since it is acid, it reacts with metal to evolve the hydrogen gas. Okay, so when acetic acid, it reacts with active metals like manganese or magnesium or zinc, it evolves the hydrogen gas. Next, it forms salt and water with bases. Okay, so what is happening? Acid and base, they react with each other, to form salt and water, and this particular reaction, it is known as neutralization reaction. Next, it liberates carbon dioxide with carbonates or hydrogen carbonates. So whenever we are taking, like for example, we have taken sodium carbonate or sodium hydrogen carbonate, it will be releasing carbon dioxide and water. Then how to form esters with acetic acid or any acid? So in the presence of concentrated H2SO4, acetic acid, it reacts reversible with alcohols and it forms the esters. So acetic acid, it combines with ethanol, okay, and it gives us ethyl acetate, which is a ester. Next is reduction reaction. So a strong reducing agent we need here, such as lithium aluminium hydride, okay. So what it will do, it will reduce this acetic acid to ethanol. Now what are the basic uses of ethanoic acid or acetic acid? Now normally in daily life we do not hear the terms like ethanoic acid or acetic acid, but vinegar, I'm very sure that every one of you might have heard this term vinegars, right? So it is same, okay. Vinegar, it is actually solution of acetic acid in which 5 to 8% of acetic acid is used in water. So ethanoic acid, it is widely used in food industries, okay, as a preservative. Then it is used in ear drops, ointments, and also in treatment of cancer. Now talking about formation of ester. So an acid, it undergoes chemical reaction with alcohol in presence of acid catalyst to form ester. So let us see how is ester formed. We are taking acid, alcohol, and it is converted to ester. So ethanoic acid, it undergoes reaction with ethanol, okay, and it gives us the ester. Now this particular reaction, it is reversible reaction, okay. So if we treat this ester with alkali, it will again give us the alcohol and the acid. Formation of ester, application of ester. So it is used in perfumes for fragrance, it is used in ice creams to give a kind of flavor. Alright, so now we will be having a quick summary of whatever we have learned in this video through a small video.
Carboxylic acids are found widely in nature. Here are 3 examples. First up, methanoic acid. Methanoic acid is commonly called formic acid, from the Latin for ant, formica, as it is the compound red ants inject into their prey. It was first isolated by distilling red ants. Secondly, ethanoic acid. Ethanoic acid is commonly called acetic acid, from the Latin acetum, meaning sour wine. This is because wine, which is a solution of ethanol, is oxidized in the air to ethanoic acid. Vinegar is a dilute solution of ethanoic acetic acid. Then, ethane dioic acid. Ethane dioic acid, commonly called oxalic acid, is toxic and is found in rhubarb leaves, and that is why we should never eat them. Carboxylic acids contain the carboxyl group, as shown in the video. This is made up of a carbonyl group and a hydroxyl group. Let's have a look at the reactions of carboxylic acids. Carboxylic acids react as typical acids. These are, number 1, acid plus metal goes to salt plus hydrogen. For example, ethanoic acid plus sodium to sodium ethanoate and hydrogen. Number 2, acid and base goes to salt plus water. For example, ethanoic acid and sodium hydroxide become sodium ethanoate and water. And 3, acid plus carbonate go to salt plus carbon dioxide plus water. For example, ethanoic acid and sodium carbonate to sodium ethanoate, carbon dioxide and water. Carboxylic acids also give another important reaction called esterification. Here they react with alcohols to give an ester plus water. An example is ethanoic acid and ethanol to ethyl ethanoate and water. This is a reversible reaction, which can be seen from the directions of the two arrows shown. In this reaction, a few drops of concentrated sulfuric acid are added. This sulfuric acid acts as both a catalyst and to remove the water formed, thereby displacing the equilibrium to the right following Le Chatelier's principle. If you don't know this principle yet, no problem. We have a video about it right here just for you. Now, let's take a look at what esters are actually used for. Esters have characteristic smells and are responsible for the flavour of foods and smell of flowers. They are therefore useful as flavourings and perfumes. Some examples of esters, together with their smells, are 3-methyl-butyl ethanoate, or bananas, pentyl ethanoate, pears, and octyl ethanoate, oranges. Animal fats, vegetable fats and oils are esters of long-chain fatty acids and glycerol. A soap is a salt of a fatty acid. Check out our water and soap video. So, to recap, carboxylic acids contain the carboxyl group. They show the typical reactions of acid. With alcohols, they undergo esterification to produce esters, and esters are used in the catering and cosmetic industries.
Alright, so we will be moving forward with this to have one discussion based question. So our question says that there is one organic compound named as A. It is an essential constituent of wine and beer. Oxidation of A, it yields an organic acid B which is present in vinegar. Name the compounds A and B and write their structural formula. What happens when A and B, they react in presence of an acid catalyst, and we have to write a chemical equation. Now see, the question number 1, it is saying that the compound A, it is essential constituent of wine and beer. So from this we know that A is ethanol, because it is present in wine and beer, and since B, it is present in vinegar, so it must be acetic acid. Okay, and now what we are doing oxidation, okay, of ethanol, and we are getting acetic acid plus water. So this is how our reaction goes. Now when A and B react in presence of acid catalyst, ethyl ethanoate is formed. So when these two are acid and alcohol, they are reacting, we are getting an ester which is ethyl ethanoate. So this is how our chemical reaction will look like. So what are the things we have learned today? We learned about carboxylic acid, and we have basically focused on ethanoic acid, and then we learned about esters, what are the uses and how to prepare. So I hope you might have understood everything in today's lesson, and this is where we come to end of this particular series. If you have missed out on any part of the series, please go and watch the videos. It will be very easy for you to catch up, and we will be meeting in the next session in which we will be learning about some new things. So till then, keep studying, keep learning. Let's meet in the next session. Thank you everyone.